Hello, my name is Juan Pablo Calderoni, and today I will be showing you my final report on the Winter Park Hotel problem situation. So for the first question, we did a linear programming model in which we can see the steps of how can you reduce costs in food preparation. In the second question, we showed a diagram which shows the steps of doing forecasting and essentially solving the question of in which states is there the fastest growth rate of tourists for a new hotel. Finally, for the third question, we made a diagram explaining the steps of the waiting line model in order to solve what can we do to improve the reception time. Besides the diagrams made, we were able to define which model would we recommend in each of the cases, and we were able to justify it. So in question number 1, how can you reduce costs in food preparation? The best model was obvious. It was to use the linear programming method due to the fact that this method is used to obtain either the maximum profit or the minimum cost possible. In this case, the linear programming method would be used to discover how to make meatballs at a minimum cost with a set of restrictions established by the chef. In question number 2, in which states is there the fastest growth rate of tourists for a new hotel? The best method to use would be the forecasting method. This method utilizes relevant facts from various years, and it can essentially predict the future growth or decline of a selected variable. With this method, the states in the country with most tourist potential can be discovered. In question number 3, what can we do to improve the reception time? The best model to use is the waiting line, because this model specifies on how to make a process shorter. Specifically for this case, it applies to the reception process of the customers. This model takes into account how much time on average does a customer takes talking with the receptionist, how much does it take for the customer to leave the line after being registered, and how many persons are on average on the line to register, and how many receptionists are on average available to register each customer. Now, moving on to our problem number 2, which is related to linear programming, we have the question, how much beef and pork should be bought? What would be the minimum cost for the restaurant in the hotel? So first, we have our objective function, which essentially is cost equals to 88, which is the price of the beef, times beef, plus 67, which is the price of the pork, times the amount of pork being bought. In our restriction equations, first we have meat, which is 0.80 times beef plus 0.68 times P, and this equation needs to be greater or equal than 0.75. And then we have fat, which is 0.20 times beef plus 0.32 times pork, and it needs to be less or equal than 0.25. Now, by using linear programming, we were able to find the minimal cost to prepare meatballs. In this case, for a kilo of meatballs, 583 grams of beef and 416 grams of pork must be used to minimize the cost down to 79.25 pesos and comply with the chef's requirement on the fat content. By using linear programming with the data given, we were also able to get a sensitivity report. Now, in the binding and non-binding restrictions, based on the data obtained in our sensitivity report, the meat and fat are binding. Therefore, there were no leftovers from either of them. Essentially, since there were no leftovers from each component, this was the optimal solution. In regards with the slack and shadow price, according to our sensitivity report, we obtained a slack equivalent to 0. The shadow price related to the fat was negative 52, while on the meat, it was 123. The relevance of the shadow price for the constraint is that for every unit that is increased in these constraints, the objective function established will rise by the shadow price value of the constraint that increased 1 unit. In this case, if we add 1 unit, the objective function can either increase by 123 or negative 72, or vice versa if a unit is removed. Now, by making this analysis, what is the relevance of beef? So, the relevance of beef, essentially the component that is more relevant in this problem, is the price of beef. Even though the fat and meat are binding, the beef has a greater impact than the final value of our objective function. It has more flexibility when it comes to increasing and decreasing it. Beef has contained more meat and has greater shadow price than pork too. Due to these facts, beef has a greater influence when it comes to the solution proposed. In our problem 3, which is related to forecasting, the first question is, in addition to Zacatecas, which other Mexican states will be used for this analysis? So, in our case, besides Zacatecas, the states that were chosen were Jalisco, Guanajuato, and Baja California Sur. Baja California Sur and Guanajuato were chosen because they are in the medium stage in tourism, meaning they have a lot of visitors but not as many as Quintana Roo or Ciudad de Mexico, the same as Zacatecas. In the case of Jalisco, it is because it's one of the most visited states in the entire country. We were also able to define the room occupation growth, which was essentially that every state reflected a growth in the room of occupation from 2010 to 2018. However, Zacatecas had the lowest growth, while Jalisco had the greatest. In regards to traveler arrivals growth, we obtained a similar result, as all the states showed growth from 2010 to 2018, and Zacatecas still had the lowest growth and Jalisco had the greatest. In the regression analysis made with the relation of tourist arrivals in Zacatecas, we obtained an S-value of 0.96. S is known for representing the average distance that the observed values fall from the regression line. And we had an R-squared of 89.2%. R-squared is known to be as the proportion of variance in the dependent variable. In Jalisco, we obtained an S-value of 0.2 and an R-squared value of 99.5%. In Baja California Sur, we obtained an S-value of 1.49 and an R-squared of 73.9%. And in Guanajuato, we obtained an S-value of 0.49 and an R-squared value of 97.2%. In the regression analysis made related to room occupancy, Zacatecas had an S of 0.97 and an R-squared of 88.9%. Jalisco had an S of 0.82 and an R-squared of 92.1%. Baja California Sur had an S-value of 1.19 and an R-squared of 83.4%. Finally, Guanajuato had an S of 0.35 and an R-squared of 98.5%. In our tourist arrival forecast made with the time analysis, our tourist arrival forecast for 2020 in Baja California Sur was 3,418,925. Then in Guanajuato it was 6,458,518. In Jalisco it was 9,907,549. And finally, in Zacatecas, it was 1,586,403. On the other hand, for our room occupancy forecast for 2020, Baja California Sur had 5,744,482. Guanajuato had 4,387,930. Jalisco had 13,376,055, and Zacatecas had 1,287,976. Now, for solution number 3, if we were to choose between a time series analysis and a regression analysis, both regression and time analysis are recognized for being statistical methods to do forecastings with sets of data. Although both work, the best analysis would be the time series analysis. The time series analysis is used to analyze every movement of the data. It can reflect the trends that occur within the data set, and essentially it has more of a complete analysis that can be interpreted easier. So for this solution, we need to discover which one is the state that has more potential. So we're basing ourselves from the information given from 2010 to 2018 in relation with tourist arrivals and room occupancy, Jalisco has the greatest potential as it has had the most tourist arrivals and rooms occupied out of the 4 states that were analyzed. Jalisco is prognosticated to have the greatest growth in both tourist arrivals and room occupancy according to the forecasting models that were previously presented.
In problem number 4, our issue is that the waiting line system in the Winter Park Hotel is inefficient. Therefore, Luis has proposed 3 different plans to improve the guest service and the time spent in the waiting line. Currently, the average customer in line is 7.92. The average customer in the system is 8.82. The average time in the system is 8.24 minutes. The average time in line is 5.21 minutes. And the probability that there are no customers in the system is 0%, while the probability that the customer will wait is a 90.9%. The first proposal of Luis is to designate an employee as a fast service employee for guests who register for corporate accounts. This is a market segment that occupies approximately 30% of all reserved rooms. Because corporate guests are pre-registered, registration takes only 2 minutes. With these guests separated from the rest of the clientele, the average time to register a typical customer would increase to 3.4 minutes. Under this plan, non-corporate guests would choose any of the remaining 4 lines. With this system, with corporate, the average customer in line would be 8.1. The average customer in the system would be 9. The average time in the system would be 20 minutes. The average time in line would be 18 minutes. The probability there are customers in the system is 10, and the probability the customers will wait is 90%. Then, on the regular line, the average customer in line would be 6.41. The average customer in the system would be 9.98. The average time in the system would be 9.51 minutes. The average time in line will be 6.11 minutes, and the probability there are customers in the system is 1.2%, and the probability the customer will wait is 89%. Now, the second proposal is to implement a single line system. All guests could form a single waiting line to be served by any of the 5 available employees. This option would require enough space in the lobby for what could be a substantial queue. With this proposal, the average customer in line would be 7.8. The average customer in the system will be 12.37. The average time in the system would be 8.24 minutes. The average time in line would be 6.11 minutes. The probability there are no customers is 1.2%, and the probability the customers will wait is 89%.
The third proposal involves the use of an ATM-like technology for registrations. This ATM would provide approximately the same service rate as an employee would. Since the initial use of this technology could be minimal, Luis estimated that 20% of customers, mainly frequent guests, would be willing to use this equipment. Luis would establish a single row for customers who prefer to be served by check-in staff where the 5 employees would be, although Luis is thinking that the technology used, in this case the ATM, allows a reduction to 4 employees at the reception. With the ATM, the average customer in line would be 1.05. The average customer in the system would be 4.65. The average time in the system would be 3.9 minutes, and the average time in line would be 52.9 seconds. The probability there are no customers in the system is 1.2%, and the probability that the customers will wait is 72%. On the other hand, with the real guests, the average customer in line will be 7.98. The average customer in the system will be 11.61. The average time in the system will be 9.6 minutes. The average time in line would be 6.59 minutes. And the probability there are no customers will be 1%. And the probability of customers that will wait in line is 64%.
Based on the data we obtained from our different waiting line method analysis, the best option is the third option. By allowing 20% of our frequent clients to use the ATM, which is extremely efficient regarding the time spent in line and in the system, it also causes a desaturation within the regular guest waiting line. With the ATM, that 20% of guests only spends 3.9 minutes in the system. At the same time, the guest from the regular line, which amounts to the 80%, spend around 9 minutes in the system. The option of having an ATM allows the flow of the line to be more efficient. Mixing two systems will allow the Winter Park Hotel to have a better service. In regards to the waiting line philosophy, the entire concept of the waiting line philosophy is to make the waiting line as entertaining and satisfying to the guests. In this occasion, my proposition to maintain the entertainment is initially to add a welcoming cocktail for each guest. These will be given out every 3 minutes so every client can get theirs. I will also add a touring guide post where the tour guides will sporadically approach the guests. This way, if any guest is interested in exploring the city, they can begin to learn about the options and different tour packages beforehand.